everyone. In today's lesson, we're going to talk about a new figure called a hyperbola. What is it? Well, a hyperbola looks like two mirrored parabolas with the two halves being called branches. Like an ellipse, a hyperbola has two foci and two vertices. Unlike an ellipse, the foci in the hyperbola are further from the hyperbola's center than its vertices, and there are no co-vertices. So, a whole new set of vocabulary words to know. For a hyperbola, the transverse axis includes the vertices, the center, and the foci. The vertices, like in a ellipse, are A units from the center and are located on the transverse axis. So it's all located on that transverse axis. Transverse axis for a hyperbola is like a major axis for an ellipse. The foci this time are inside each of the branches, and again, like an ellipse, they are C units from the center. Hyperbolas have asymptotes, which we'll talk about in a minute, and the conjugate axis helps us determine the B value, which helps us create a box to make the equations of the asymptote lines. And this time, since C is greater than A, this changes the formula to find A, B, or C. So the formula is going to be C squared equals A squared plus B squared. All right, let's take a look at what these pictures look like. So, a horizontal hyperbola is a hyperbola that has two branches opening horizontally. A vertical hyperbola is these two branches opening vertically. Now, I discussed before that the vertex, the center, and the foci lie on what's called this transverse axis. And then this conjugate axis helps us find these values right here. Now, the sole purpose of these values, they don't have a label, but they are B units from the center, right? If you want to label that in here, you absolutely can. So here, this is B units from here to here, right? B units from the center. Those values actually help us get these four corners here, 1, 2, 3, 4, and they make this box, which helps us create our asymptotes for our branches, okay? Now, how do these equations look? So if we take a look down here, here are our equations of our hyperbolas. So how are they different than ellipses? Well, we have an x squared over a squared minus this time, not a plus, y squared over b squared equals 1. Same scenario here, so we have a minus sign. That's the first difference. The second difference is if I want to get a horizontal hyperbola, the x squared is going to come first. So this x squared will be first. But if I want a vertical hyperbola, the y squared will come first. So notice it's a little different. In an ellipse, the bottom numbers are switching, but in a hyperbola, the top numbers are switching. So you could say here the x squared comes first, therefore it's a horizontal. If the y squared comes first, it's vertical. Notice A and B never change. You can feel free to write that if you would like. A and B never change. So that's really the main difference between an ellipse and a hyperbola. All right, now that we talked about all of the definitions, now I think you're ready to graph. So let's take a look at example number 1. So the first thing we want to do is decide if it's a horizontal or vertical hyperbola. Well, we have to look, does x squared come first or y squared come first? Since the x squared comes first, it's going to be a horizontal hyperbola. And if you want to write y, it's because the x squared comes first. Now, in a hyperbola, the first number will always be a squared and the second number will always be b squared. So that tells me the square root of 25 is 5 for my a, the square root of 1 is 1 for my b, and my center comes from these values up here. And my center is just like the way a circle works. So it's really x minus 0 squared plus y minus 0 squared. Therefore, my center is 0, 0. Now to get the vertices and the foci and the equation of the asymptotes, we have to graph. So let's go ahead and plot what we have so far. All right, so my center is at 0, 0, so I'm going to go ahead and plot that there. And my vertices will lay on the transverse or major axis, if you want to think of it that way. So we're going to go 5 to the right, we're going to go 5 to the left, and we'll call this V1, and we'll call this V2. The B value will help us create this box. So since the B value is 1, we're going to go up 1 from the center and down 1 from the center. And I'd like to connect all of these points, the vertices and the B1 and B2 values, and create a rectangular box around the center, centered around that center point. And this will help us create our asymptotes. So our asymptotes, the way that it works, it goes through the corners of each of the boxes. So this would be one point of the line, this would be the other point, and this would be the third point. So technically, this line going this way is up 1 over 5, down 1, left 5. So that would be my slope of the line. And we're going to connect these dots with dotted lines because technically the asymptotes are not actually part of the graph. Now, hopefully your picture looks better than mine, but that's the asymptote there. Then do the same thing here, here, and here, and connect them with dotted lines because they're technically not part of the graph. So now you're pretty much 90% there. If you want to graph your ellipse now, all you're going to do is graph the two branches, hyperbola. Here's the vertex, and the one branch goes in between the two asymptotes, and the other branch goes between these two asymptotes. So this is your horizontal hyperbola. So now let's see if we can answer the questions. The vertices are here and here, which are at -5, 0, and 5, 0. And the foci can be found by using the equation c squared equals a squared plus b squared. Notice a different formula for a hyperbola than an ellipse. So the c squared is what we want to find. A squared is 25 and b squared is 1. So c squared is equal to 26, and we can take the square root of both sides, and we get that c is equal to the square root of 26. And I don't think 26 has any factors such that one of them is a perfect square, so we can go ahead and leave it in that form. So basically, we need to figure out the decimal equivalent to 26. Well, we know that the square root of 26 will be in between the square root of 25 and the square root of 36. We know the square root of 25 is 5 and the square root of 36 is 6. So the square root of 26 is probably a little bit bigger than 5. So you can go ahead and estimate and just put it right there, and we'll call that foci 1, and 5 from the center here we'll call foci 2. And that would be our graph. And then the last part is just finding the equations of these asymptotes. So remember, an asymptote is just a line. It's a line that's in the form y equals mx plus b, where m is the slope and b is the y value of the y-intercept. So if we take a look at this equation going this way, right, this line, the y-intercept is clearly 0, so b will be 0. And to get the slope, we just go rise over run. So I'm rising 1 and going right 5 to get to this point. So my slope is up 1 over 5, x plus 0. So that is really y equals 1/5 x. That's the first one. Now my other asymptote is this line going down this way. Again, still at 0 is my y-intercept, but this time to go from this point to this point, I'm going up and left. So I'm going up 1 and left 5, so that's a negative, and then plus 0. So my y equation of this asymptote is -1/5 x. And that's it. That is my equation of my asymptote. Now I just realized we never actually put the points of these foci, so I'm going to do that right now. So technically this foci is left radical 26, comma 0, right? It's not up or down anything. So it's -rad 26, comma 0. And then this point over here is over positive rad 26, and then comma 0. So that would be the other foci. All right, now I'd like you guys to move on to number 2. I'd like you to try this one on your own, and then hit resume when you're ready for the answer. All right, here are your answers. All right, a couple things that I just want to point out. This is a vertical hyperbola because the y squared comes first. Since the y squared's coming first, that tells us it's a vertical. Now, if we needed to find the center is still x minus 0 squared plus y minus 0 squared. So the x would still come first when making the center. So it's 0, 0, so it doesn't matter, but I just wanted to point that out. We have our a's, our b's, and then my foci, which I actually didn't label, they're going to be somewhere here, 7.7, somewhere around here, foci 1 and foci 2. So the coordinates would be 0, and then the y value would just be radical 61, and then 0 comma negative rad 61. All right, that's it for today. Come to class with questions tomorrow. I know this is a different shape, so it's okay if you're having difficulty, and we'll see you in class tomorrow. Have a good night.